Hello dear students! In this video, we'll explain a new topic in Chapter 2, the Lewis dot symbol. In the preceding videos, we've explained how to locate an element in the periodic table, where the group or column is identified by the number of valence electrons. However, the row or period is identified by the number of occupied energy levels. And simple elements located to the left of the stirred top line are metals, and they fall in groups 1, 2, and 3. However, elements next to the stirred top line are metalloids, and they are boron and silicon in the first 20 elements. And elements to the right of the stirred top line are nonmetals and fall in groups 4, 5, 6, 7, and 8. Elements of group 1 are called alkali metals. Elements in group 2 are called alkaline earth metals. Elements in group 7 are halogens. However, elements in group 8 are inert or noble gases. And in this video, we'll cover the following objectives. Relate the chemical stability of inert gases to their electronic configuration. Identify the valence electrons, and represent the first 20 elements according to Lewis dot symbol. Prepare your materials and let's start. Consider a portion of the periodic table. We know that elements in column 18 are called inert gases, and these gases are chemically stable and do not react readily with other elements. But what is the reason behind the stability of these inert gases? To answer this question, consider the three noble gases or inert gases: helium He, neon Ne, and argon Ar. Let's remember how to write the electron configuration of each. For helium having only 2 electrons, the electron configuration will be K2. For neon having 10 electrons, 2 electrons will fill the K shell, and 8 electrons will fill the L shell. For argon having 18 electrons, 2 electrons will fill the K shell, 8 electrons will fill the L shell, and the remaining 8 electrons will fill the M shell. What's the number of electrons found on the outer energy level, or the outer shell? For helium, it is 2 electrons. For neon, the outer shell is L, which contains 8 electrons. And for argon, the outer shell is M shell, and also it contains 8 electrons. We know that the level K can never hold more than 2 electrons, while levels L, M, and N can hold 8 electrons each. So what do we conclude? We conclude that inert gases are chemically stable for having full or saturated outer energy level. Note that the outer energy level is also called the valence energy level or valence shell. Consider the three elements hydrogen, neon, and chlorine. You have to indicate the valence shell of each. For hydrogen, the outer energy level is K, so the valence energy level or valence shell is K. For neon, the outer energy level is L, and that of chlorine, the outer energy level or valence energy level is M. Could you give a name to specify the electrons found on the valence shell? Great, they are called the valence electrons. Let's apply together. Consider the three elements helium, neon, and aluminum with their atomic numbers. We have first to distribute the electrons and then indicate the valence shell and the number of valence electrons. Don't forget that the atomic number Z is equal to the number of protons, and in a neutral atom, the number of protons is equal to the number of electrons. So the number of electrons for helium is 2. These electrons will be distributed on the K shell. Then the K shell is the valence shell, and the number of valence electrons are 2. For neon, 2 electrons will be distributed on the K shell and 8 electrons will be distributed on the L shell. Then the valence shell is L and the number of valence electrons are 8. For aluminum, having 13 electrons, 2 electrons will fill the K shell, 8 electrons will fill the L shell, and the remaining 3 electrons will fill the M shell. Then the outer shell is the valence shell, which is M, and the number of valence electrons is 3. A scientist named Lewis suggested a way to represent only the valence electrons by dots around the symbol of the element, where each dot represents one valence electron. Steps of writing the Lewis dot structure of an element. We have 3 steps to be applied when writing the Lewis dot structure. The first step is writing the electron configuration of the element. The second step is indicating the number of valence electrons. And the third step is distributing the valence electrons by dots around the symbol of the atom, where each dot represents one valence electron. First, we have to apply steps 1 and 2 together, where we have to write first the electron configuration and then indicate the number of valence electrons. In writing the electron configuration, we have to mention that the atomic number Z is equal to the number of protons, and in a neutral atom, the number of protons is equal to the number of electrons. Then, the electron configuration of hydrogen having Z equal 1 is K1, and the number of valence electrons is 1. For boron having Z equal 5, then the electron configuration is K2L3, and the number of valence electrons is equal to the number of electrons on the outer shell, then it is 3. For carbon having Z equals 6, the electron configuration is K2L4, and the number of valence electrons is 4. For oxygen having Z equal 8, the electron configuration will be K2L6, and the number of valence electrons is equal to the number of the electrons on the outer shell or valence shell, then it is 6. For chlorine having Z equals 17, the electron configuration will be K2L8M7, and the number of valence electrons is 7. For argon having Z equal 18, the electron configuration will be K2L8M8, and the number of valence electrons will be 8. In step 3, we have 2 hints. Hint 1. For atoms having a number of valence electrons less than or equal to 4, these electrons are represented by odd dots placed on the 4 sides around the symbol. Example 1. Writing the Lewis dot symbol of hydrogen atom. First, we have to write the electron configuration of hydrogen, which is K1. The number of valence electrons is 1. This electron will be placed on one of the 4 sides of this hydrogen atom. This is the Lewis dot symbol of the hydrogen atom. For writing the Lewis dot symbol of boron atom, the electron configuration of boron is K2L3. The number of valence electrons is 3. These 3 electrons will be placed as odd dots on the 4 sides of the boron atom. For writing the Lewis dot symbol of carbon atom, the electron configuration of carbon is K2L4. The number of valence electrons is 4, and these 4 electrons will be placed on the 4 sides of the carbon atom. They will be placed as odd dots. We cannot place 2 dots beside each other. Now, hint 2. For atoms having a number of valence electrons greater than 4, the first 4 valence electrons are represented by odd dots placed on the 4 sides around the symbol. and the remaining electrons will be successively added to the first four. Example 1, writing the lowest dot symbol of oxygen atom. The electron configuration of oxygen is K2L6. The number of valence electrons is 6, which is equal to the number of electrons on the outer shell or the valence shell L. In writing the lowest dot symbol, the first 4 electrons will be distributed on the 4 sides of the oxygen atom, and then the rest 2 electrons will be added successively to the first 4. The lowest dot symbol of chlorine atom. The electron configuration of chlorine is K2L8M7. The number of valence electrons is 7. In writing the lowest dot symbol, the first 4 electrons are distributed on the 4 sides of the atom, and the remaining 3 electrons will be added successively to the first 4 to get this lowest dot symbol. The lowest dot symbol of argon atom. The electron configuration of argon is K2L8M8. The number of valence electrons is equal to the number of electrons on the outer shell M, or valence shell, which is equal to 8. In writing the lowest dot symbol, the first 4 electrons will be distributed on the 4 sides of the argon atom, and the remaining 4 electrons will be successively added to the first 4. Then this is the lowest dot symbol of argon atom. Now it's your turn to write the lowest electron dot symbol of the first 20 elements in the periodic table. You can pause the video, solve, and then check your answers. Elements of column 1 have only one valence electron, and it can be placed on one of the 4 sides when writing the lowest dot symbol of the atom. Elements of column 2 have 2 valence electrons. Elements of column 13 have 3 valence electrons. Elements of column 14 have 4 valence electrons, and they must be distributed as odd dots on the 4 sides of the atom. Elements of column 15 have 5 valence electrons. The first 4 electrons will be distributed on the 4 sides of the atom, and the rest electron will be added to the first electron. Elements of column 16 have 6 valence electrons. The first 4 will be distributed on the 4 sides of the atom, and the remaining 2 will be added successively to the first 4. Elements of column 17 have 7 valence electrons. The first 4 electrons will be distributed on the 4 sides of the atom, and the remaining 3 electrons will be added to the first 4. Atoms of column 18 have 8 valence electrons. The first 4 electrons will be distributed on the 4 sides of the atom, and the remaining 4 will be successively added to the first 4. For helium, it is an exception, and you have to keep in mind that helium is an inert gas. It is located in column 18 or group 8, but it has 2 electrons on shell K. It's chemically stable for having a saturated valence shell. Then the lowest dot symbol of helium will be He, and the 2 electrons will be placed beside each other on one of the 4 sides of the helium atom. From the lowest dot symbol, we have to know that the pairs of electrons are also called the non-bonding pairs of electrons, while the single electrons are called the lone electrons.